Okay, we're going to consider the indefinite integral x times the square root of x minus 1 dx. Now, the instructions in this particular problem says evaluate the integral in b. Well, the integral in b is the one that's written above there that we're supposed to consider. And we need to remember that the square root of u is u to the 1/2, which we should remember from algebra. And observing that it is now possible to rewrite the integrand in u by expanding through multiplication. All right, well, despite those instructions, it is possible to use substitution to solve this, rewriting the integrand in terms of u. So your typical choice that you would make based on habit, or I guess what your teacher teaches you, is that you would let u be the thing that's inside the composition, x minus 1. But then you know that du is plain old dx. And we don't seem, as sits here, to have a substitution for this x. But, you know, we can manipulate this to do anything we want. As long as we make the initial choice for u, we can do pretty much anything else we want with it, legally, you know, right, within the rules of algebra. But I can say that based on this implies that if I add 1 to both sides, that x is equal to u plus 1. Do you agree? I mean, that is true, right? If u equals x minus 1, then x equals u plus 1. So now watch what happens when you do this with that substitution. My integral of x, the square root of x minus 1 dx, now becomes, well, x is defined as u plus 1, so I'm going to put u plus 1 in place of x, and x minus 1 is u. There we go. And then dx is du. That's a really cool way of substituting when it doesn't look quite like it's going to work. So oftentimes, if these have the same powers, so if this is degree 1 and that's degree 1, or this is degree 2 and that's degree 2, you can still use substitution as long as you can solve for the independent variable after you've defined what u is. Okay? Should I say that again? Well, you know what? You can rewind and hear that again. All right, now if I go ahead and integrate this, this is where the problem's talking about, noting that this is true and multiplication and all that stuff. So I can say that this is equal to the integral of u plus 1 times the quantity u to the 1/2 du. Then through multiplication, or the distributive property of multiplication over addition, this becomes u times u to the 1/2. And so if I have u times u to the 1/2, think about what that is, how to simplify that. Plus 1 times u to the 1/2 du. So I add these powers, remember? So 1 plus 1/2, don't write 1 1/2 as a power. You know that 1 1/2 is 3/2. So this is u to the 3/2 plus u to the 1/2 du. Integrating that, I add 1 to the power. So this becomes 5/2 divided by 5/2, and then this becomes u to the 3/2 divided by 3/2 plus c. Let me move this up just a little bit to finish. So I can to simplify this complex fraction, I just take the reciprocal of the denominator and multiply. So 2/5 u to the 5/2 plus 2/3 u to the 3/2 plus c. And then, of course, since I started in x, I have to end in x. And remember from above, it says u equals x minus 1, so I need to substitute that in at the very end. So this is equal to 2/5 times x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3/2 plus c.